That's the power of one of these asteroids. 10,000 Hiroshima bombs is the power packed by this piece of real estate a mile across.
Apophis, an asteroid regarded as one of the most dangerous of its kind, is on its way towards Earth. In 2029, scientists predict it will come extraordinarily close to Earth. This phenomenon, enabling billions around the world to see it with the naked eye, is an extraordinary event that happens only once in several thousand years. However, while this might be a unique scientific event, why are scientists so concerned with studying it at a closer range? And could this event be potentially deadly for life on Earth? Let's find out. Named after the ancient Egyptian god of chaos and destruction, Apophis seemed to live up to its name. This naming reflected scientists' genuine concern about its path. Initially, they estimated a 2.7% chance of Apophis colliding with Earth in 2029. That means that it may be unlikely, but not impossible. So, how big is this space rock? Apophis is about 340 meters wide. To put that in perspective, it's longer than 3 football fields put together. This not even the biggest asteroid out there, but it's already big enough to cause catastrophic destruction if it hits Earth. Its remarkable path around the Sun really got everyone's attention. Apophis has an orbit that brings it close to Earth every few years. In fact, in 2029, it will come really close, about 32,000 kilometers from Earth. That might sound like a lot, but in space terms, it's a hair's breadth. This asteroid will pass closer to us than some satellites that orbit our planet. What makes this particularly startling is that the calculation about Apophis's orbit is a mere estimate. Scientists aren't sure if the number will be exact, and it might end up being much different in reality. Notably, Apophis completes an orbit around the Sun roughly every 0.9 Earth years, traveling at a tremendous speed of about 30.73 kilometers per second. Its proximity, size, and velocity all contribute to its classification as a potentially hazardous asteroid. Moreover, Apophis is an Aten-class asteroid, which means its orbit intersects with Earth's. The asteroid's encounter with Earth's gravity could also influence its future trajectory, adding an extra layer of unpredictability. Scientists are particularly interested in how Apophis's orbit will evolve after the 2029 approach, as it will help refine calculations and predictions for other near-Earth objects. This close pass provides a rare opportunity for detailed study, allowing astronomers to observe its physical characteristics like rotation, shape, and surface features in greater detail than ever. Understanding the path of Apophis is about learning how asteroids move and behave. The more we know about Apophis and asteroids like it, the better we can prepare for future space rocks that might not be so kind to our planet. From its discovery in 2004 to the ongoing observations, this asteroid has been a wake-up call for scientists everywhere, reminding them of our solar system's dynamic and sometimes unpredictable nature and the importance of keeping our eyes on the sky. Recently, scientists made a headline-grabbing announcement about Asteroid Apophis, and it's something we should all pay attention to. So, what's the big news? Apophis is returning for a visit, and this time, its journey is causing quite a stir in the scientific community. Why are scientists and space agencies concerned? There are a couple of reasons. First, an asteroid this size coming this close is a rare event. It's a unique opportunity for scientists to study Apophis up close, which can help us learn more about asteroids in general. But there's more to it than scientific curiosity. The real worry comes from the potential risks of such a close approach. While scientists have ruled out a collision with Earth in 2029 for now, the path of Apophis is influenced by various factors that make predicting its future trajectory tricky. One of these factors is the Yarkovsky effect, a force that acts on an asteroid because it absorbs and re-emits solar energy. This effect can slightly alter the asteroid's path, making long-term predictions more challenging. The Yarkovsky effect works like this. As the asteroid spins, one side is heated by the sun, while the other cools down. When the hot side rotates away from the sun and cools, it emits infrared radiation, which gives a tiny but constant push to the asteroid. This push, over time, can cause significant changes in the asteroid's orbit. Interestingly, the direction and magnitude of this effect depend on several factors, including the asteroid's size, shape, rotation, and the properties of its surface material. The Yarkovsky effect can be more pronounced for smaller asteroids like Apophis, making their paths more susceptible to change. This is why scientists are keen to study Apophis's thermal properties and rotation rate during its close approach. Such observations will also help improve the models used to predict the Yarkovsky effect on other asteroids. Understanding Apophis's trajectory is critical because, even though we're safe in 2029, its future visits might pose a risk. The gravity of Earth during the 2029 flyby could change Apophis's orbit, potentially putting it on a collision course with Earth in the future. Scientists are working hard to map out all possible paths to ensure we're not caught off guard. So the recent announcement about Apophis is a call to action. It's a reminder of the dynamic and ever-changing nature of our solar system and the importance of monitoring these celestial objects. Apophis's return is an opportunity for us to understand these space rocks better and prepare for any future threats they might pose. Apophis's upcoming visit is crucial for asteroid research and planetary defense. The work done by scientists and space agencies now will help ensure the safety of our planet in the years to come. In response to the challenges posed by asteroids like Apophis, NASA and other space agencies worldwide have ramped up their efforts. Their mission? To keep an eye on these space rocks and develop strategies to protect our planet. One of the standout missions in this field is NASA's OSIRIS-REx mission. Launched in 2016, this spacecraft had a rendezvous with Bennu, another near-Earth asteroid. The mission was a huge success. OSIRIS-REx managed to land on Bennu, collect a sample, and bring it back to Earth in September 2023. Studying these samples up close gives us vital insights into the composition and behavior of asteroids. The OSIRIS-REx mission, which stands for Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer, was groundbreaking in more ways than one. It was the first U.S. mission designed to return a sample from an asteroid back to Earth, aiming to uncover more about our solar system's history and evolution. The spacecraft traveled for 2 years before reaching Bennu, a journey of approximately 500 million miles. Upon arrival, it performed a detailed survey of the asteroid's surface, mapping it in high resolution to select the safest and most scientifically interesting site for sample collection. The touch-and-go sample acquisition maneuver performed by OSIRIS-REx was a delicate and challenging operation involving briefly touching the asteroid's surface with a robotic arm to stir up and collect dust and pebbles. The mission gathered a substantial sample and provided unprecedented insights into Bennu's physical properties, such as its density, spin, and thermal characteristics. But NASA isn't stopping there. Building on the success of OSIRIS-REx, they've launched a new mission called Osiris Apex. This time, the target is none other than Apophis itself. The plan is for Osiris Apex to observe Apophis closely during its 2029 flyby. The spacecraft will study the asteroid's structure, composition, and possibly even how its surface reacts to the close encounter with Earth. Osiris Apex, which stands for Origins, Spectral Interpretation, Resource Identification, Security, Apophis Explorer, is designed to enhance our understanding of Apophis. The mission will utilize the expertise and technology developed during the OSIRIS-REx mission and apply it to this new target. One of the key goals of Osiris Apex is to gather detailed information about Apophis's physical characteristics, including its size, shape, rotation, and surface features. This data is essential to refine predictions about the asteroid's future trajectory and potential Earth impacts. With the data collected, scientists hope to learn more about Apophis and gain broader knowledge applicable to other near-Earth objects. Now, why go to all this trouble for one asteroid? The answer lies in the importance of being prepared. By studying Apophis, scientists can fine-tune their models and predictions for other asteroids that might pose a threat in the future. Besides these missions, NASA and other agencies are working on various projects to track and analyze asteroids. They use powerful telescopes and radar systems to keep tabs on these objects. The goal is to identify potential threats as early as possible and have enough time to react if needed. In the grand scheme, missions like OSIRIS-REx and Osiris Apex are part of a larger effort to protect our planet and ensure that we won't be caught off guard if a dangerous asteroid ever heads our way. Asteroid monitoring might sound like something straight out of a sci-fi movie, but it's a real and crucial part of space science. Predicting the path of an asteroid is a complex task, filled with challenges and surprises. One of the major hurdles in predicting asteroid paths is the Yarkovsky effect. Now, you might wonder how scientists keep track of these space rocks and predict their paths, especially with something as unpredictable as the Yarkovsky effect. The answer lies in a mix of advanced technology and meticulous methods. The answer is telescopes. Both ground-based and space telescopes are the eyes of our planetary defense system. They scan the skies, looking for asteroids and tracking their positions and movements. But seeing these space rocks is just the first step. Scientists need to analyze their orbits to understand their paths, which is where radar comes in. Radar systems, like the ones used by NASA, can bounce radio waves off an asteroid. Scientists can calculate the asteroid's distance, size, shape, and speed by measuring how long it takes for the waves to return and the frequency changes when they do. This data is crucial for building accurate models of the asteroid's orbit. But tracking and predicting asteroid paths isn't a one-time job. It requires continuous observation. Why? Because space is a dynamic place. Things are constantly moving and changing. So scientists keep updating their models with new data, refining their predictions, and maintaining a vigilant eye on these cosmic wanderers. Thus, the science behind asteroid monitoring combines sophisticated technology and ongoing vigilance. It's about using every tool, from telescopes to radar, to keep track of these asteroids. The goal is clear: to understand where they're headed and ensure they don't catch us by surprise. In the vastness of space, these efforts are our best bet at keeping our planet safe and one step ahead of any potential threats from above. When discussing asteroids like Apophis, it's natural to wonder, what if it hit us? While the chances of Apophis colliding with Earth are currently low, it's important to understand the potential global impacts of such an event and how the world prepares to prevent a disaster. So, what would happen if Apophis did strike our planet? Even though it's not the largest asteroid out there, at about 340 meters wide, Apophis could cause significant damage. An impact would have global consequences. The immediate effect would be a massive release of energy, leading to widespread destruction in the impact area. Depending on where it hits, this could mean the leveling of entire cities or regions. But the aftermath would extend far beyond the crater. One of the biggest concerns is the dust and debris thrown into the atmosphere. This could block sunlight, leading to what's known as an impact winter. Crops could fail, temperatures could drop, and ecosystems would struggle to cope with the sudden change. It's a chain reaction that could affect the entire planet, disrupting food supplies, economies, and lives. In addition to these direct effects, the impact could trigger secondary environmental disasters. For instance, the shock wave from the collision could set off earthquakes and volcanic eruptions around the globe. These geological disturbances would further compound the ecological crisis, potentially leading to more long-term climate effects. The dust and ash spewed into the atmosphere from such events could remain aloft for years, exacerbating the cooling effect and prolonging the impact of winter. This prolonged period of reduced sunlight would affect agriculture and disrupt global weather patterns, potentially leading to extreme weather events in different parts of the world. Furthermore, the economic impact of such a disaster would be enormous, with costs running into the trillions as nations struggle to cope with food shortages, infrastructure damage, and other challenges. The social and political fallout could also be significant, as governments and communities grapple with the immense task of recovery and rebuilding in the aftermath. The good news is that scientists and space agencies worldwide are working on planetary defense strategies. These efforts aim to detect potential threats early and develop ways to deflect asteroids away from Earth. One of the key strategies is the kinetic impactor technique. This involves sending a spacecraft to collide with an asteroid, altering its trajectory just enough to avoid Earth. Think of it as giving the asteroid a small nudge off its path. NASA's Double Asteroid Redirection Test mission is a prime example of this approach. The double asteroid redirection test is designed to test the kinetic impactor technique on a smaller asteroid's moonlet, demonstrating how we could change an asteroid's course. The target for the double asteroid redirection test mission is the moonlet of the asteroid Didymos, known as Dimorphos. This binary asteroid system was chosen because it poses no real threat to Earth, making it a safe testing ground for the mission. The spacecraft, named DART, is relatively small, weighing about 600 kilograms. It is equipped with innovative technologies, including the Next-C ion propulsion system, a cutting-edge technology that could be used in future deep space missions. The double asteroid redirection test mission also carries sophisticated scientific instruments. One of the key instruments is the Didymos Reconnaissance and Asteroid Camera for optical navigation. This is an essential component, providing the necessary high-resolution images of the asteroid and its moonlet, which are crucial for navigating the spacecraft to its target. Another groundbreaking aspect of this mission is its use of an autonomous navigation system. This system utilizes algorithms to process the images taken by camera, allowing the spacecraft to adjust its trajectory in real time. This level of autonomy is vital for missions like the double asteroid redirection test, where reaction times are too short for human controllers to intervene effectively. The goal is to hit Dimorphos and slightly alter its orbit around Didymos. By doing so, the double asteroid redirection test will help scientists understand how much force is needed to change the course of a potential Earth-threatening asteroid. This is particularly important as it provides empirical data that can be used to validate and refine our theoretical models of asteroid physics and collision dynamics. This mission is crucial because it's the first time humanity will actively attempt to change the dynamics of a solar system body measurably. The success of the double asteroid redirection test could pave the way for future asteroid deflection strategies, providing a real-world test of our ability to prevent a potentially catastrophic asteroid impact. The spacecraft, equipped with cameras and navigation technology, will autonomously guide itself to the asteroid, ensuring the highest level of accuracy for the collision. Furthermore, the mission is part of a larger collaboration with international space agencies. The European Space Agency is planning a follow-up mission, Hera, which will arrive at the Didymos system a few years after the double asteroid redirection test's impact. Hera will closely study the crater left by the previous mission and measure the moonlet's mass. This data will be vital in understanding the efficiency of the kinetic impactor technique. Another strategy under consideration is the gravity tractor method. This involves a spacecraft hovering near an asteroid, using its gravitational pull to alter the asteroid's path slowly. It's a gentler approach than the kinetic impactor, but it requires more time to be effective. The concept behind the gravity tractor method is to use the mutual gravitational attraction between the spacecraft and the asteroid to create a slow but steady force that changes the asteroid's orbit over time. The spacecraft, equipped with precision thrusters, would maintain a specific distance from the asteroid, ensuring a constant gravitational tug without the risk of collision. This method is particularly suitable for larger asteroids, where a kinetic impact might be less effective or a more gradual adjustment of the asteroid's orbit is necessary. One of the advantages of the gravity tractor method is its controllability. The spacecraft can adjust its position relative to the asteroid to fine-tune the gravitational force exerted. This method also allows long-term interaction with the asteroid, providing ample opportunity to study its properties in detail while altering its trajectory. Additionally, the gravity tractor approach would not require the spacecraft to come into direct contact with the asteroid, reducing the risk of fragmenting or accidentally accelerating the asteroid. This makes it a potentially safer and more predictable option for planetary defense. International collaboration is key in these efforts. Space agencies like NASA, European Space Agency, and others share data, technology, and resources to enhance our collective planetary defense capabilities. This collaboration extends to tracking asteroids, sharing early warning systems, and developing joint missions to test and refine deflection strategies. But here's some good news. As scientists have kept a close eye on Apophis, they've gotten better at predicting its path. They've used powerful telescopes and radar to track its journey through space, and with each passing year, they've refined their calculations. The latest data shows that Apophis will miss Earth in 2029 and its subsequent flybys for at least the next century. Many near misses of asteroids predicted to hit Earth have occurred throughout history. In 2002, an asteroid about the size of a football field flew past Earth, missing it by only 120,000 kilometers, a whisker away in cosmic terms. Named 2002 MN, this asteroid was not detected until 3 days after its closest approach. Its late discovery highlighted the need for more robust tracking systems to see these near-Earth objects, NEOs, sooner. Then, 2011. A small asteroid known as 2011 MD passed just 12,000 kilometers above the Earth's surface. This distance is so close that it's below the orbit of geostationary satellites. Measuring about 10 meters in diameter, the 2011 MD wasn't large enough to pose a significant threat. However, its proximity was a reminder of the number of undetected asteroids in near-Earth space. Another well-known asteroid is 99942 Apophis. Originally thought to pose a significant risk of impacting Earth in 2029, Apophis is about 340 meters in diameter. Initial observations suggested a 2.7% chance of collision, causing considerable concern. Fortunately, further analysis ruled out this possibility, but Apophis symbolizes the potential dangers lurking in space. In 2013, an asteroid named 2012 DA14 came within 27,700 kilometers of Earth. About half the size of a football field, this asteroid's approach was notable because it was closer to Earth than many artificial satellites orbiting our planet. Its flyby provided a unique opportunity for astronomers to study a near-Earth asteroid up close. 2018 VP1, a small asteroid, captured public attention in 2020 due to a small chance of hitting Earth right before the U.S. presidential election. Measuring only about 2 meters in diameter, it wouldn't have posed a significant threat even if it had entered our atmosphere, likely disintegrating upon entry. The interest in 2018 VP1 highlighted how asteroid monitoring has become part of public consciousness. In 2019, an asteroid named 2006 QQ23 approached Earth closely, coming within 7.5 million kilometers. Although this distance is relatively safe, the asteroid's size, about 570 meters in diameter, reminded of larger asteroids' catastrophic potential. These close encounters with asteroids remind us of our planet's vulnerability. They show the importance of investing in space monitoring and defense technologies. By tracking these near-Earth objects, we can learn more about our solar system and develop strategies to protect our planet from potential future impacts. Each asteroid that whizzes past Earth is a nudge for humanity to look up and prepare, ensuring that we will be ready to respond if a significant threat ever emerges. While considering an asteroid impact is daunting, the global community is not idle. We're preparing to protect our planet through international cooperation and innovative strategies. By understanding the potential risks and actively working on deflection techniques, we're taking steps to ensure that if an asteroid like Apophis ever poses a real threat, we'll be ready to respond. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable.